Hey everybody, here we are with quiz 4. This is a second quiz on alcohols. So let's start with this one. Question 1. What's the only possible way to do the following reaction with the stereochemistry of the major product indicated? So I'm trying to get not inversion, but retention of stereochemistry. So now many of these reagents are going to give you inversion though. SOCl2 thionyl chloride gives you inversion because Cl attacks from behind. So that's not that one. TSCl attacks from the O, so then you'll make OTS, so that one maybe, but then if you do Cl minus, it's going to come in from the back, so that's not going to work either. PBr3 and then NaCl, okay, well if we do PBr3, we're going to get this turning into, again, inversion, right? But then if we do Cl, then hopefully we're going to do inversion again. So we invert and invert again. So overall, it gives you net retention. So that could work. And Cl minus is a good nucleophile. If we do, so that's a potential answer. And then Grignard reagent with chlorine instead of bromine, which is okay, but we have CH3 group. We don't want that, right? And TMSCl, that just changes this to a OTMS group, which is a protecting group, and then we reverse it to get the OH back, so that's not it. Okay, so the emphasis on this one is stereochemistry, understanding how those reactions work. A lot of reactions work with SN2, where you have backside attack, and then exception to that would be H3O plus, or H2SO4 concentrated gives you this. And we don't really, we have Br minus. We're going to have carbocation rearrangement, and then you can have attack of the halogen, whatever halogen you use on either side. So you want to be careful that using some kind of acid to create a good leaving group and then having this attack, usually it occurs by SN1, especially for secondary and tertiary alcohols. And then you'll get retention. All right, question number 2, what's the best way to do this? Notice what's changing here. So I've just copied it onto my notepad here. So what's changing is this part, and it's not just a reduction here, we're also alkylating. So to me, it's not hydride, it's Grignard, okay? So we need Grignard. And what Grignard reagent we need is we already have one methyl group here, and what we're trying to do is add a second methyl group. So I need to add a methyl group. So I'm going to use a methyl Grignard, CH3 MgBr, but the problem is, and we saw this in the last quiz and on the practice materials as well, this Grignard is going to probably prefer any kind of protic group on there, like a hydroxyl group or an amine or something with a hydrogen on an electronegative atom. That's an acidic site, right? Acidic. So, yeah, that's going to be a problem because instead of attacking here, it's going to take the hydrogen instead. So we need to use a protecting group. Okay, so my first step is going to be using TMSCl, trimethyl silyl chloride. That's going to convert this to OTMS, and then I'm going to do the methyl Grignard, and then I'm going to attack here, going to add a methyl group in the process and reduce this to O minus. And then my third step would be either water workup or dilute acid, either one's fine, and that's going to allow this to pick up a hydrogen and neutralize. And then this is OTMS still though, okay, and so we have to take care of that at the very end. Instead of OTMS, then we'll do TBAF. TBAF to get rid of the OTMS group, and you don't need to know the mechanism for that so much. Just use it for synthesis where you need a protecting group, okay? This next one is looking specifically for methods that could produce 2-butanol. So as long as you could make 2-butanol, it doesn't say the best method to minimize side products or anything, or the least number of steps. It just says a method that makes 2-butanol. So let's try it. You could just go through each one. So ethyl bromide. This is an electrophile. Oh, I think I meant to put ethyl magnesium bromide here. I better correct that. So ethyl magnesium bromide. Oops, sorry. I'll go back and fix that. So that would attack there. And and then I would get this. Either that, if this was ethyl magnesium bromide, then that would be the answer, and it would be a possible product. But I wonder maybe if I kept it the way it was. If it's ethyl bromide, that's not good enough, right? Because this is actually not a nucleophile like Grignard. It's actually an electrophile. And this is an electrophile. So I would basically have no reaction. So in order to get to butanol, I'd have to have ethyl magnesium bromide. Make my ethyl nucleophile using the Grignard reactions. It's the only way to do it. So I'm going to have to go back and either remove this as an answer choice, or I'm going to have to change that to ethyl magnesium bromide. Okay, same thing here. This is not going to attack here unless it's ethyl magnesium bromide. Then it will attack. And then oxidation of that would, so let me work it both ways just in case. So if I had ethyl magnesium bromide, then it could attack. I would get this, and then PCC is going to oxidize that. So that's not 2-butanol, so that shouldn't be the answer. And then what's stated here is ethyl bromide, so that's definitely not going to attack. So this is not going to work for either of those reasons. LAH, if that attacks, that's the hydrogen nucleophile, and I get reduction. Okay, so I'm going to have O minus, and then it's going to get protonated in the second step to OH. And this hydride is on here. PBr3 should take this primary alcohol to an alkyl halide. Magnesium will turn this into a Grignard reagent. Reaction 4 will allow me to attack for acetaldehyde. And then I will get MgBr. Mg comes off then, and I end up with OH like that. And this is going to be water workup will make this neutral. So this actually does work. This is 2-butanol. Step D, okay, so I have 1 mole of this, so that can either side can take the H. Then that will become the acetylide ion, which is a nucleophile, and that will attack ethyl bromide. So we have ET, and 1 mole means I only reacted one side. And then I do this steps 3 and 4 on an alkyne. Remember, that does anti-Markovnikov. Addition of water, and I get an enol there, which then tautomerizes. So I end up with 1-butanal or butyraldehyde, 1, 2, 3, 4. But it's an aldehyde, not 2-butanol, so D doesn't work. And E could do the same thing here and then attack here. So we're adding a methyl group, but we have 3 carbons. And then I do my reaction on this, gives me this, but then I do step 4. So this is step 3. We'll do the oxidation here, or we'll do the addition of water, sorry, not oxidation, addition. And then I will do a reduction, that's step 4. Step 4 is reduction to make an alcohol. So this does work as well. So the proper answer should be C and E. I think I accidentally thought this was Grignard, but it's not, so there should be no reaction for part A. I'll have to fix that in the quiz. Question 4, when 1-propanol is oxidized using PCC, then remember PCC is milder and we can't go all the way to the carboxylic acid. So 1-propanol, the oxidation series is propanaldehyde, or propanal. And then if I had a strong oxidizing agent, it could go all the way to the carboxylic acid. So to stop it here, I have to use PCC, which is weaker. If I want to go all the way, I got to use like Jones reagent, which is chromium trioxide, H2SO4, or sodium dichromate, or some of those other reagents, CHEM&262. Any one of those options is fine for that. So I'll make an aldehyde for it with PCC, but with any other option, I'd make a carboxylic acid. I make a carboxylic acid with CHEM&262 also being a strong oxidizer. You could see with all these oxygens, a very strong oxidizer. And so try the second one as well. I'll leave that for you, okay? Which reagents and in what order do you need for this synthesis? So I put it here. Some ideas on that are, well, I clearly need to get rid of that and just start over and put an OH group separately on a different place. So what I would do is get rid of this OH group. Now, several ways to do that, right? I know some of you are thinking, oh, I need to make that into a good leaving group, and that's correct, but which leaving group and which method? If I use TSCl and I make this into OTS, that's a good idea, but then I need to do an elimination, right? So I need to do a second step just to get rid of it then. So maybe like I would use NaOH and heat, or I would use KOTBU and heat. Either one doesn't matter because it gives me the same alkene. It gives me the same double bond no matter what base I use, right? So that's 2 steps to get my alkene. But there's actually a better way, which is 1 step. And the 1-step way to do this is noticing this is tertiary. Lets me do HX and heat, okay? So once I get HBr, HCl, whatever, and heat will give me this. So this is my E1 reaction done in 1 step. And then from there, you could probably see I need anti-Markovnikov addition of that. So that's going to be BH3THF, and then there's a follow-up step to that to finish that off. You need NaOH, H2O2. That's chapter 8, alkene reaction, okay? All right, so you could do that in 3 steps if you don't use TSCl or SOCl2 or PBr3. Those are going to require an extra step. Which reagents do you need for this synthesis? So let's take a look at that in more detail here. So, my eye is sort of going toward just getting a grasp of what, this structure is, and recognizing that I'm moving reactivity from here's where the carbonyl group is, right? And I'm moving it toward here. So there's reactivity in between. So I'm really focused in on this whole region right here. So what I need to do is get rid of this O, obviously, and I need to do an elimination of some kind to get the double bond. So if I convert this into an alcohol, then I know I can eliminate an alcohol, either changing it into a good leaving group, or if it's secondary or tertiary, I could do acid and heat. So maybe I'll use that theme of, okay, first I need a reduction to turn this into an OH group. Now, one tip for you guys, I don't like to juggle too many things in my head. I like to just think of what molecule structure needs to happen, and then I think of the reagents separately, just so that I don't get it all screwed up. So I think, okay, first I'm going to convert that to an alcohol, and then from there I should be able to get to there. Okay, so now that I have the idea down, now I can try to figure out what the reagents are that I need. So I'm going to take that down. I have a lot of students who confuse oxidation and reduction. So this is reduction. I know that because I'm adding an H here and I'm taking a CO bond away. So what I need to do is use a reagent with H. Okay, so this is like LaH or NaBH3. BH4. Either of those are reducing agents that will work fine for this, okay? Once I have that, then again, I could do 1 step. This is a secondary alcohol here. So my options are I could do HX and heat, but secondary can go either way. So I could also convert this to a bromine or a chlorine. So it just depends on what the options are that we have. I could also make it tosylate it, right? So a tosyl chloride there. So that, yeah, looking at those options, it looks like HX isn't on there. So let's go ahead and use the only option. So of course, step 1 is to reduce the ketone to an aldehyde, or sorry, to an alcohol, and then eliminate it. First, we got to put a good leaving group on it. The option being TSCl is the only one for a good leaving group that is on this list. And then we need to eliminate it using a strong base and heat. Now there are options for a bulky base or a small base, and of course we want to use the small base to get Zaitsev. Now in this next question, Notice it's the reverse of what we just did. So we're going from the alkene now to the ketone. And looking at that more in depth, notice we did a reduction and then elimination. Here, I need to probably do an addition and then do the reverse of reduction, which is oxidation. So I can see ketone. So I'm thinking, okay, I need more CO bonds, oxidize that. So what I'm going to do is do an addition first. I know I need to add a group here, and preferably one with an O in it, so I don't have to add more steps. I know some of you are thinking HBr peroxide, but then that puts a Br here, and then you have to switch it with an O later, and so why not just go ahead and start with the O? So let's do that. First step is going to be, well, hold on, let me practice what I preach. I usually do this where I just sketch it out, and I find the path first. That way I don't waste too much time going back and switching back and forth. Oh, think of what molecule, think of the reagents, think of the molecule, think of the reagents. I just do all the molecules first, sketch it out, and then I think of the reagents. Okay, anti-Markovnikov is BH3THF, and that might not work for all of you, by the way. I know some of you need to know what reagents you have before you move on, and it's not a bad idea if you can switch like that. That's totally fine. All right, so that gets me through the first step, anti-Markovnikov addition here. And then I challenge you to think of what oxidizing agent you could use to transfer or to transform this OH group into a carbonyl group. Okay, so sorry, that's a question mark. You figure that out, okay? Do some work there. Okay, so hopefully should be obvious to you where my oxidizing agents are in this. Okay, it's not H+, by the way. A lot of people think acids are oxidizers, and not necessarily. Okay, nitric acid is, but they don't all work that way. All right, which reagents do you need for this multi-step synthesis? And I'm noticing I have almost the same thing except for this group right here, an ethyl group. So I'm going to need an ethyl group to attack the carbonyl. Grignard reagent's going to be involved. Okay, so ethyl group, maybe ethyl magnesium bromide where ethyl attacks. But if I do that, and by the way, backwards thinking on this would tell me that the new thing is right here. So that's how I got this. And this is negative and this is positive. So I knew it was going to be an ethyl group nucleophile of some kind. There's different ones you could use, right? We've used things like this before. That's an ethyl group nucleophile as well. But these usually attack alkyl halides like RX. Right? We're used to that from chapter, the alkynes chapter. Grignards love to attack carbonyl groups, so try to link those together when you can. Okay, so here we are, ethyl group, but this is going to be OH because after neutralization, dilute acid workup, we're going to have H on here. So what I'm now focusing on is the transformation there. Again, is it oxidation or reduction? That's some kind of oxidation, and I want you to think of what reagent you could use there. You could probably use the same thing you used up here, okay? Next reaction says minimize unwanted side products. So try not to get a reaction where maybe you have a carbon and now you have the same substitution here. It's secondary and secondary. So it's going to be really hard to control if the OH ends up there or an OH ends up here. You could end up with both products, right? A ketone here or ketone here. So you want to be careful to make sure that if you have a ketone in one spot, that you don't also have a chance for a byproduct where you have ketone here as well. So I want to be careful of that when I do the synthesis. That's what they mean by minimize side products. Okay, or splits is another way to think about it. Okay, so thinking about the product and thinking about this, I have 2 carbons off the ring, 1, 2. So I'm adding a carbon group. I'm also transforming alkyne into a carbonyl group of some kind. Wow, so how do we do that? There are several things you might be thinking about. Like for me, I know you can use NaNH2, and you probably are thinking this first, and then you do CH3I and you attack here. But again, what's the problem with this? Can I then get only this ketone? I can't, because I'm also going to get the carbonyl here. This is exactly what I was talking about before. You can get carbonyl here and carbonyl here. So in order to do this asymmetrically, I'm going to need to think of a different way. So I'm thinking maybe some kind of a Grignard reaction. Okay, and it can attack a carbonyl, and I can oxidize it back to ketone. That's the common theme here. So let's maybe try converting this to a carbonyl first, and then we can do the methyl Grignard. So CH3MgBr. So see, there's a very common theme of using the Grignard reaction followed by a workup, H3O plus in a second subsequent step, and then I do oxidation. So step one, though, has to be how do I get an alkyne into an aldehyde? So that's R2BH THF, NaOH H2O2. Then I do my Grignard reagent and workup. And then step 5, I need some kind of oxidation to go from an alcohol to a ketone. And here's where you can use anything like PCC, sodium dichromate, chromic acid, any of those, chromium trioxide or Jones reagent. Okay. And the last one is a really long one. That's because I'm starting with an alkane. Alkane, there's really only one thing to do, right? Add a functional group to it, so then we can apply our other reactions. So hopefully you're already thinking, I got to put a BR on there. And then I want to spread that reactivity from here across to those 2 carbons. So I want to try to make a double bond there. And then I want to add a group. I want to add a group here, something there. What do you think would go here? I could add a BR. I could add an OH. I could add, so many things there. What could I add? And the tricky thing is, I need to have a way later for a carbon group to get added on. Now, is it likely? There's only 2 reactions that add carbon. One was this on an alkyl halide, and the other was Grignard. Okay, Grignard reagent on a carbonyl group. All right, or carbonyl, or later you learned you could also use an epoxide. Okay. So I'm probably going to do this. So if I do that, then I'm going to make this a BR. And then I'm going to take the BR and I'm going to insert magnesium. And I'm going to make this a Grignard. And then now this is my negative charge here. And I'm going to find a 1-carbon electrophile that's a ketone or aldehyde. Okay, so that's basically formaldehyde. Just use a 1-carbon carbonyl group, and this will attack here, and that's how you add 1 carbon unit. Okay, so if I do that, I get this, and then I neutralize it, and this oxygen grabs the hydrogen. I'm almost there. I just have to get rid of that O, right? So how can I get rid of that O? Well, this is primary. Some people might say you could use acid and heat, but on primary, it's probably better just to do make that a good leaving group and then do elimination. So maybe I will make this either tosylate, or I could make it bromide, or I could make it chloride. So either TSCl or PBr3 or SOCl2. Just make it a good leaving group, tosylate, bromide, or chloride, and then eliminate it with a strong base and heat. There's only 1 alkene you can get, and once you get here, then all we have to do is hydrogenate it, and we have this. Okay, so really long. All right, but I think you got the idea of how to go about that, and that's why we have 8 steps for this one. Okay, so work it out, make sure you understand each step, and then see what clues there are for, the different branching points. Like I sort of emphasize, like when you put a BR, there's only one thing you could do, right? So that's not a branching point. What I mean is divergent thinking, like There's only one thing you can do there, but here there's multiple things. Like you could eliminate it this way, or you could eliminate it this way. And it's really important to know that both options are there, and it's important to know how you get each one. This is with bulky base, this is with strong base. KOTBU versus NaOH and heat, okay? Heat is nice to add in, but sometimes we don't always do that. And then here, we had options here. Is it an OH we want to put here, or is it, what are the different options? Try to challenge yourself to think, wow, once I got here, what are all my options and which way do I want to go? That's the hard part, because you have to look a step ahead to tell what you're going to do next. Or you can entertain that thought, oh, what if I try this? What can I get? And then you'll run into a dead end and you'll have to go back. So as much as you can look ahead, you'll save some time. But, just do the best you can to at least see the different pathways and quickly go through them and then realize it's a dead end or it's the correct way to go. Okay? All right. Good luck, everybody.